Good afternoon and welcome to lecture 5.3. We're going to look at the sum and difference identity for the cosine function. We're also going to look at some cofunction identities again, and then look at several applications of these. So our first identity is the cosine of a sum or a difference. So notice if we have two angles A and B, and we want to take the cosine of their sum, the cosine of A plus B, this equals cosine A times cosine B minus sine A sine B. Similarly, if we want to take the cosine of the difference between two angles A and B, the cosine of A minus B, here we get cosine A cosine B plus sine A sine B. So the helpful hint here is to remember that the cosine sum and difference identities are opposite functions. That is, the cosine of a sum is actually a difference formula, and similarly, the cosine of a difference is actually a sum. So that's just a little trick to kind of help you memorize these, okay? So let's see how this might work. Find the exact value of cosine of 15 degrees. Now remember, when we're talking about exact values, we're not talking about decimals, we're talking about fractions, we're talking about known angles, not these long ongoing decimals, if you will. So, it's kind of a setup here, but we are trying to figure out how do we find two known angles that when we add them together or subtract them, we can get 15. Well, think about what we know as known angles. We've got 30, 45, 60, 90, etc. Okay, so if we wanted to find 15 degrees, notice that we know what the cosine of 45 is. We know what the cosine of 30 is, and the sine, and all of those. So if we take 45 minus 30, we will get 15. So if we do this, then we can just simply plug in the values. So we have the cosine of a difference, which of course is cosine A, cosine B, plus sine A, sine B. Okay. Again, these are our known triangles, or known angles, if you will. The way I've taught it in class is to know the triangle. So all you have to do now is plug in the values. The cosine of 45 is square root of 2 over 2. The sine of 45 is square root of 2 over 2. The cosine of 30 is square root of 3 over 2. And the cosine of 30, 1/2. Multiply out and add, and we get the square root of 6 plus the square root of 2 over 2. Okay. What if we have the cosine of 5 pi over 12? Now, this is very similar. Now, I imagine that you, and I've been in math obviously a lot longer than you all have, but radians still aren't something that are quick for me to recognize in my common knowledge, okay? And so the first thing I want to do here is to convert 5 pi over 12 into degrees. I do that for my own help, because I want to do just like we did in the last time. How do I make 15 degrees out of the angles that I know? Okay, so here we have 5 pi over 12 equals 75 degrees, and you should know the conversion for this, right? Multiply by 180 over pi to turn that into degrees, excuse me. So here I know that if I add, well, what do I have? If we do 30 and 45 again, but this time adding them, 30 and 45, right? Because a 30 degree, we know those angle measures. We know those trig functions. We know the 45. So instead of subtracting 30 from 45, we're going to add it this time. And remember that 30 is pi over 6 radians, and 45 degrees is pi over 4. Okay? So here we're going to add those two things. Again, it helps me to think in terms of degrees. It's just more of my common knowledge. Again, because we have a sum, we're taking the cosine of a sum of two angles, then the formula is cosine cosine minus sine sine, etc. We know these values, we plug them in, and we get the square root of 6 minus the square root of 2 over 2. You may have taken a little bit longer if you had to build the triangles to know what those measures are, or to build the unit circle, whatever. But make sure that you can do those. Take your time and pay attention to the details of this. Find the exact value of cosine 87, cosine 93, minus sine 87, sine 93. Well, I can see here that this is the setup for either the cosine of a sum or cosine of a difference. Because it's a difference here, and I know that the cosine, sum, and difference are opposite functions, I know this is the cosine of the sum of these two angles. So this expression, cosine 87, cosine 93, minus sine 87, sine 93, is equivalent to the cosine of the sum of those two angles, 87 plus 93. When I sum those, I get 180 degrees. And if you think about the unit circle and cosine being the x value, then of course the cosine of 180 degrees is -1. Okay? So you can see in this problem, it's important to kind of recognize both sides of the equation, the identity, and to be able to go in either direction and know what to do. We saw these cofunction identities before, that sine and cosine are cofunctions, meaning that together they add up to a complementary angle. So the cosine of 90 minus theta is equal to the sine of theta because these two angles are complementary. That works the same with tangent and cotangent and secant and cosecant. Okay, that the trig function of one value is equal to its cofunction's trig function of the complementary angle. The same identities can be obtained for a real number domain by replacing 90 with pi over 2. Of course we know this. This is just moving from radians, from degrees to radians, and it works in either notation, if you will. For example 2, we're going to be using those cofunction identities to find a value of theta. These are pretty simple because we know that the cotangent angles have to be complementary. Find one value of theta or x that satisfies each of the following. Cotangent of theta equals the tangent of 25. This simply means that these angles theta and 25 have to add up to 90. So if we rewrite the left side of the equation, that the cotangent of theta, which could be written as the tangent of 90 minus theta equals the tangent of 25, then we can see that these angles have to be equivalent. 90 minus theta has to equal 25 in order for this statement to be correct. And so we get theta equals 65. To me, it's just as easy to see that theta plus -30, since these are cofunctions, has to add up to 90. And in this case, then it would be theta equals 120. Okay, but if you need to go through this process, that's fine. Everyone, we each have our own way of looking at things, thinking about things, etc. And here we can see that if we rewrite sine theta as cosine, so we have cosine equals cosine, then we can drop the trig function and just set these numerical equations and expressions equal to each other. Find one value of theta or x that satisfies the following. 3 pi over 4 equals the secant of x. So remember that these have to be x plus 3 pi over 4 has to equal pi over 2. Again, we can rewrite it if we choose to do so. Both of these in terms of secant or cosecant, as they've done here. You could have rewritten either one, honestly. And actually, I think I would do this one instead, because then I can get the measure, but that's neither here nor there. Then it sets up as an automatic problem without a negative variable. Okay, But 3 pi over 4 equals pi over 2 minus x, and that gives us x equals negative pi over 4. These are pretty straightforward. Again, know that if you have cofunctions and they are set equal, then the angles have to be complementary. They have to add up to 90. Okay. Now, in all of these examples, note that the solutions that we gave were not unique. What does this mean? That we gave only one solution and there are infinite many possibilities. Well, you might remember this, that we discussed this earlier with the idea of coterminal angles, that if we rotate around the circle one more time, around the graph, around the origin, we come back to that same angle, but it's 2 pi radians later or 360 degrees later. So again, we could just keep rotating around because these are indeed very periodic to get multiple answers for each of these, just by adding 2 pi or 360 degrees to the angular measures. Okay. Applying the sum and difference to a quadrantal. So it's interesting that if either angle A or B in the identities for cosine A plus B and cosine A minus B, if either A and B is a quadrantal, then the identity allows us to write the expression in terms of a single function of A or B. Well, this is pretty intuitive. Think about it. What does cosine equal at each of the quadrantals? It either equals 1, 0, -1, or 0, right? So if it equals 0, then it's going to make one of those factor products disappear. If it equals 1, it's going to stay the same, and if it equals -1, then it's just going to change the sign. So this kind of makes funny. So I'm sorry. It makes sense. So let's try a problem here. Write cosine 180 degrees minus theta as a trig function of theta alone. So we're just going to use our trig difference identity. So it's cosine 180 times cosine theta plus sine 180 sine theta. Okay, that's just applying the identity. Well, what is cosine 180? Cosine represents the x value, and at 180 it's going to be -1. Sine at 180 represents the y value, and at 180 is 0. So notice what happens here. We get -1 times cosine theta plus 0 times sine theta. Well, the 0 sine theta disappears, and we're just left with negative cosine theta. And that's what this is talking about, that if we are dealing with any of the quadrantals, then we're going to be able to reduce it to a single function of either A or B, one of those two angles. Okay. Now this is an interesting problem, and we're actually going to solve this problem in two different ways. Obviously, you do not have to use two different ways, but one method may kind of make more sense to you or be easier for you. Okay? So the first method is we're going to use the graphing method, kind of how we started out in trigonometry with sine and cosine and doing x or y over r, or opposite over adjacent. Okay, so notice here we are given the sine of s, which is 3/5, and the cosine of t, which is -12/13, and we're asked to find cosine of s plus t. Well, we know that the formula for this is cosine s cosine t minus sine s sine t. So we're missing two parts here. We also need sine of t, and we also need cosine of s, as we can see here. So how do we find those? Well, the first method, we're going to use the graphical method, okay? And so we're going to, recognizing both of these, by the way, are in quadrant 2. And we know that sine of s in quadrant 2 is positive 3/5, okay? Well, remember from before, we can think of sine as being the y value over r. And remember that r was the radius from the origin to the point. So if we let y equal 3 and r equal 5, we can graph this in quadrant 2. Remember, the radius is 5, The r value is 3. Now we have to figure out x. Well, how do we do that? It's a simple Pythagorean theorem, right? A squared plus b squared equals c squared, or x squared plus 3 squared equals 5 squared. And then we get x squared equals 16, and x equals plus or minus 4. Well, look where we are. We're in quadrant 2, so is x positive or negative 4? X is, of course, negative 4. And if we wanted to find cosine here, cosine is x over r. You know, and it's interesting to me because even these sine equals y over r, I've kind of let that go once we've got out of that section. And I always think now in terms of opposite over hypotenuse or adjacent over hypotenuse. And remember that while this angle is s, this angle here is the reference angle for s, so it works the same way. So the sine of s is equal to the sine of this angle, which is opposite over hypotenuse. The cosine of this angle s, reference, is adjacent over hypotenuse, so we see that as well. So we found one of our values, and we just need one more. We're going to do it the same way. We're going to use cosine t equals negative 12 over 13. Again, x over r, and graph that. Okay, when we do that, again, we're in quadrant 2. We can see that. We can find y the same way by using the Pythagorean theorem, and we get y is plus or minus 5. We know in quadrant 2 that y is a positive value, so the sine of t is going to be equal to that y value over r, which is 5 over 13. Remember, r is always positive. We never consider r to be negative, that ray that's coming out of the origin. Okay, so once we have all 4 of our values, sine s, sine t, these were given in the problem, cosine s that we've calculated, and sine t that we calculated, we just plug all these values into our identity, do the multiplication and addition, and we get as a final answer 33/65. Okay. Now, starting over with this same problem, we can also find sine and cosine, the ones that are missing, by simply using the Pythagorean identity. Remember, sine squared plus cosine squared equals 1, so we can just plug in the cosine that we're given, square it, and then subtract it from 1 and figure out the sine by taking the square root. And similarly, the sine value we were given, we can plug it in here and then calculate the cosine. So that's exactly what we're going to do. We were given that sine s equals 3/5, so we plug that in, and so we can find the cosine of s because these have to be the same angle. When we do that, we get cosine equals negative 4/5. Now remember, when we're doing this method, we have to figure out whether we're going to use the positive or negative square root. Cosine is negative in quadrant 2 because cosine is connected to the x value, which is negative in quadrant 2 and 3. We're going to do the same thing for the other angle. We were given cosine t. Plugging that into the Pythagorean theorem, we can find sine squared t by subtracting the cosine squared t from 1, taking the square root, and then checking here. Again, sine is related to the y value, and in quadrant 2 it is positive. Okay. From this point, you can see we got the same values, so we're not going to calculate the final answer again, but you can kind of figure out which one is easier for you to do. I personally, although it's a little more involved, like the graphing method because I think it helps build on the knowledge and the concepts like that cosine is x values, sine are y values, connecting the y over r with the opposite over hypotenuse, etc. So I just think it's a good practice to kind of reinforcing your skills, kind of like when you go to the gym and you keep lifting that weight to strengthen yourself. And so to me, that method is a little more strengthening of our knowledge base for this course. Okay, now we have one of those great electricity examples again. Very common in trig. So common household electric current is called alternating current, AC, because the current alternates direction within the wires. It goes back and forth. The voltage V in a typical 115 volt outlet can be expressed by the function V of t equals 163 sine omega t, where omega is the angular speed. We saw this before, this letter before, in this idea, this concept of angular speed in radians per second of the rotating generator at the electrical plant, and t is measured in seconds. Okay. A. It is essential for electric generators to rotate at precisely 60 cycles per second. 60 cycles per second, so household appliances and computers will function properly. Determine omega for these generators. Well, omega, remember, is the angular speed. We just saw that in the last. So, and it's telling us here that this is moving, this is rotating, which is creating an angle at 60 cycles per second. So everything we need is in this part of the problem. We don't even need the formula before. If the generator is rotating at 60 cycles per second, how many radians or degrees is that per second? Well, a cycle is just going around the circle one time. So if it goes around the circle 60 times per second, how many degrees are radians? And it told us before that omega should be in radians, okay? Well, how many radians is one cycle or one circle? It's 2 pi. So each cycle, if we go 2 pi radians for each cycle and 60 cycles per second, notice what we have here is 120 pi radians per second. This is a great problem that students get stuck on constantly because they're overthinking it. It's rotating at 60 cycles per second. It's going around 60 circles per second. How far is one circle? One circle is 2 pi. So what is its speed? 120 pi radians per second. Okay? All right, so don't overthink these things, or try not to overthink these things. It asks us to graph the function v in the window 0 by 0.05. Oh, this is the x and y values by negative 200 to 200. You can plug this in your calculator and just see what it looks like. It's a good idea to do that. Why don't you hit a pause for a minute and try that? It's a good little problem to do. Okay, determine a value of, I think that's omega, so that the graph of 163 cosine, again, my Greek is bad. That's actually omega t minus phi, I think. I think that's a phi. Minus phi is the same as the graph of v of t equals 163 sine omega t. Sorry about my Greek letters, but we can see here that these are the same thing with one fundamental difference, and that is that we're subtracting another angle. Well, what do we know about the cosine and sine of when will they be the same? They're the same if these two angles are what? If they're complementary. So WT plus WT minus theta equals 90 degrees, right? Well, remember that the sine of x equals the cosine of 90 minus x, or pi over 2 minus x, which you can see on the right side here, okay? Now what it's doing here is it's trying to set this up so that it's visually the same, okay? And so let's work from the right to the left. So we're starting here, and this is just our basic cofunction identity on the right side of the equation. Cosine pi over 2 minus x equals sine x, okay? Well, remember that cosine's negative angle identity says the cosine of a negative angle is the same as the cosine of the angle. So the sine of x is also equal to the cosine of negative pi over 2 minus x. Well, if we multiply this through and do distribution, we get negative pi over 2 and positive x, which is the same thing as x minus pi over 2. So notice here we can have the cosine of an angle minus 90 will equal sine of that angle. And notice that's the setup we have here. 163 times the cosine of an angle minus another angle equals 163 sine of that first angle. So here it shows that phi must be equal to pi over 2. Okay. All right. Aha, you thought you were going to get away without doing a verification today. No such luck. The secant of 3 pi over 2 minus x equals the negative cosecant of x. Verify that the following equation is true. Okay? So, let's see. What do we want to do here first? Well, secant is 1 over cosine. So let's change that. And now actually we have to figure out which side is more complicated. And certainly the left side is a little bit more complicated than the right. We have the secant of the difference of two angles. Well, with today's lecture, we know we've been dealing with the cosine of a difference between two angles. So the first thing we want to do is change the left side into cosine, or secant equals 1 over cosine. So notice we get 1 over cosine of 3 pi over 2 minus x. Well, we can then use the cosine of a difference identity to rewrite this as cosine, cosine, sine, sine, with a plus in the middle. Okay? Notice that 3 pi over 2, which is also the same as 270 degrees, which is the negative y-axis, is a quadrantal. So the cosine of 3 pi over 2 and the sine of 3 pi over 2 have known values. The cosine of 3 pi over 2 on the y-axis is actually 0, and the sine of 3 pi over 2 is going to be negative 1. Okay, so here we get 1 over negative sine of x, and of course 1 over sine of x is the cosecant, so we get this equal to negative cosecant of x, which of course is the same as the right side of the equation, and so the given equation is indeed an identity. And that's the end of our lecture for today. Have a good afternoon.